Hey guys, my name is Joe Mordecai. I am the founder of Voxo, and in this video, we're going to go through how to set up Vitess in a multi-region, multi-cluster environment using GKE. The reason for this video is primarily I was not able to find any resources online that kind of helped me through setting up the operator in a fashion where I could get a single cluster working across multiple GKE clusters and have replication take place and using Orchestrator in that way. As far as multi-region goes, there's a few resources out there. There's one or two videos from some Google I/O events or Foundation events, I think, but there's no like how-to kind of tutorial video that I've been able to find. So I was able to successfully kind of pull this off myself, and wanted to make sure that I've seen a lot of people asking about this. I've seen a lot of people chatting about it and trying to figure out how to make it work in GKE or any other hosted Kubernetes environment. So I'll go ahead and get started here. There's a few things that I'd like to kind of cover first from a topology perspective and a just some challenges that I've faced kind of getting into this, and hopefully anybody that's watching this can take some of the things that I've done and hopefully make it better as well. So what we are doing is setting up a multi-region, multi-cluster, basically a multi-GKE cluster, Vitess operated deployment with one Vitess cluster, no sharding. This is a single shard. So there's also like a bunch of different operators out there. Like Press Labs has one. There's a few others. Percona has one. ExtraDB, and I wasn't really able to make those work in a way that was really scalable and was really expandable. So I kind of went this route and stuck with Vitess. Seemed like the best solution for what I'm trying to accomplish. So we're a voice over IP company, and our platform and our system and our software relies on multi-region. So we have to be able to have availability in multiple regions. We have to be able to fail over masters to MySQL masters to multiple regions. We have to have really fast reads in local regions. So we have to make sure that our reads are super snappy, and that we have something like Orchestrator helping us automatically elect new masters when one fails, and this seems to work really well in the Kubernetes environment. I'm just going to kind of demo that and show you kind of the process that I went through to set this up. I haven't tested this with like an AWS environment connected to a GKE environment, but I'm assuming that you can make that work with VPC peering between AWS and GCP. So long as that the pod IPs are able to discover each other, and that you have some type of service discovery layer happening between them, between the two hosting providers. I know that Vitess, like the Planet Scale guys, recommend, or they use in their own environment, Cilium. I believe it's called Cilium Cluster Mesh. That's for a Vitess deployment on a single hosting provider like GKE only. Then I think Cilium is a little bit overkill. You don't need all of the extra bloat, because you can accomplish this with Google's new MCS, multi-cluster service, and I'll show you how all that works. So Just a quick architecture view, kind of documented here what everything does and how it functions. So basically, we're dealing with two cells right now. We're dealing with a central Vitess cell in US Central 1 and another GKE cluster in US East 4, and that's called the East cell. And you can see that they're basically, each one of these environments are very similar to one another, except for the fact that we have global ETSI cluster in our central location. So each cell has its own cell local etcd clusters, but one of the cells has a global cluster that all of the other local cell clusters communicate with to discover one another and discover like VT tablets and VT gates and in the various regions. So we have, 2 or more VT gates in each region. These VT gates are all able to discover one another, as well as VT tablets in each region, and they can do cross-region reads. They can do cross-region writes, and having everything inside the same VPC in GCP allows all the pods to discover each other's IPs, and so that Orchestrator can elect a new master from another cell if it needs to, and I'm going to go through a demo and just show you how to like manually elect a new cell and that kind of, or elect a new master, a VT tablet master, just manually and using Orchestrator. So this is kind of a very basic way of the way that I understand how it's set up. I'm not at all an expert in any of this. I'm very much a beginner related to Vitess Operator and Vitess itself. More of a MySQL person, but I can kind of understand how the dots connect. So this is kind of my brained up on a diagram here, just kind of show you how I see it working. This may not be accurate. And I just want to make sure that I'm saying that so that I don't get any kind of expert related questions related to this. So you can see that everything here is named accordingly, and in my YAML files, everything is named according to this as close as possible. So I have a Vitess demo GitHub repo that I'm going to share. All of the links and websites that I'm referencing will be linked below the video so that you can see like the PlanetScale API docs, which is how I was able to put all of this together, and as well as the GitHub repo with every single thing in the demo that you can use to stand up your multi-region Vitess cluster. So you can notice here that there's only one master here, and there's an array of VT tablets in different regions. VT tablets are discoverable across regions because they're all in the same VPC, even though I have 2 GKE clusters. In each region, and I'll go through the YAML files and kind of show you in detail how this region is able to communicate with this region. For instance, how the East region is able to communicate with the Central region. And it's actually very easy. It's very minimal work. It didn't take a lot to get it up and running as soon as I started understanding the components a little bit more. So hopefully it's had some clarity, and we'll kind of get into it here. What I'm using here is, so I had a couple of options. One option is to use Google's new internal global load balancer. So Google has like a newer feature that allows an internal load balancer to be discoverable across multiple regions, so that you're not exposing your services to the outside world. They're just discoverable within your VPC globally. I chose not to go that route, but you could make it work, I believe, with internal LBs. But the reason I chose not to go that route and instead use Google's new multi-cluster service is you would have to do some like manual YAML work, or create like a Helm chart to discover your internal IPs, or use some static IPs, or whatever. So using Google's multi-cluster service was the best way that I could kind of and most easily deploy this and create a demo for it. So you can notice here as well that the Vitess Operator is deployed in both regions. And then also Orchestrator is deployed in both regions. All of this that you see here is easily done with just a few YAML files, and there's really no custom configuration that needs to be done except setting up the multi-cluster service APIs in Google. So let's do a demo. Pretty much through this process, I followed the PlanetScale Operator API and just kind of became more familiar with it. Helped me set this up. So I am starting with two GKE clusters, a central and an east. They both have 3 nodes. They're just basic clusters, no custom configuration whatsoever. Just went ahead and created these for the sake of time, and I believe the context is already added to my terminal here. So first thing we want to do is create 2 clusters. Obviously, that's already done. Add the kubeconfig context for both. I'm going to make sure that my contexts are already added, and it looks like they are. So I'm going to proceed here. Okay, the first thing we're going to do is enable the necessary G-Cloud services and APIs for a multi-cluster service discovery. I've just created a little bash script here that you can run with these arguments, and I'm basically going to go ahead and enable. It's going to enable all the APIs. It's going to add my 2 clusters to a hub, the multi-cluster service hub, and it's going to assign them a membership and enable the different policies for them to be able to communicate with one another. I'm going to kind of show you how that works. So let's go ahead and run this. I'm going to pass in my project ID, the zone, and the cluster name. And now it's deploying its own connector inside the cluster itself. So the way that I understand how MCS works is in each cluster, there's like a listener or some kind of agent that's running. And every 5 minutes, there's a syncing process that happens between your clusters to sync any service exports that you perform within each cluster, so that your domains, like your cluster set.local domains, are able to discover each other and route to their own service IPs within each cluster. So we've got east added. I'm going to add central, and then we're going to run like a membership list to make sure that both of our clusters have been added. And I'll kind of show you what that looks like in the Google Cloud Console. Cool. So we're going to list the memberships and just confirm. Cool. So we have both of our clusters there added, and go into workloads here, and we can see that our Connect agent is running in Central. The Connect agent and the MCS importer is running in East. Let's give it a little bit more time. Yep, so it's also running in. Okay, I'm just going to kind of walk you guys through some of these YAML files that we have here. First is the Vitess Operator. You can grab this. There's nothing special about the operator. It's all just from the Vitess GitHub repo. We're creating a namespace to put everything in here. It's called VoIP. And we have defined some secrets. We've defined a secret for database users for Vitess with the username Vitess and password. And then a secret for database connection string for Vitess. As you can see here, we're deploying our own VTGate service. I'll show you what that looks like here in just a second. But by default, the reason that we're doing this is because the Vitess operator deploys its own VTGate service, but its naming schema is not. It's different every time. So we just want to deploy our own so that it's we already know it's going to be, so we can go ahead and deploy the secret. I'm going to go ahead and deploy the secrets to both clusters. And I'm going to make sure that I'm in Central. So go ahead and deploy the secrets to the Central cluster. Oops. First we have to create the namespace. So go ahead and create the namespace in both clusters. Then we can deploy the secrets. Cool. So now we've got the secrets deployed. We've got our namespace created. And now we can go ahead and deploy our operator if we want.
Open your eyes, what can you see around?
Go back to East, deploy the operator here as well. Cool, so now we should have the operator in both clusters. Yep, sounds like we do. It looks like we do. So at this point, we can take a look at the differences in these two folders, East and Central. So let's start with Central first. The first thing that we're going to want to deploy is a global etcd cluster. And what we have here is from the PlanetScale operator etcd lock server, we are giving it a name of global, and we are putting it in the VoIP namespace, and we're creating a service export. This is the service name that we're creating for the service so that the global etcd cluster can be discoverable using Google MCS in any other cluster within our project. And then we are also deploying a regular cell local etcd cluster, and also exporting a service for that cluster so that it can also be discoverable to other local cells in other regions. So I'm going to go ahead and deploy this. I'm going to make sure that I'm in the Central. Control. And deploy this. And now I'm going to go ahead and deploy my local cell etcd cluster as well. And we're going to flip over to our east cluster and deploy our local cell east cluster there as well. Okay, so we've deployed, let's look at our workloads in Central. And you can see that these pods are spinning up. We have these are our local cell etcd nodes. These are our global pods. That is a global lock server for all of the Vitess regions, or all of the GKE regions. So let's look at our services real quick. Now, you'll see some strange like MCS services here, and then you'll see like the deployed Vitess lock server services here. So these are actually services that Google deploys themselves with with their own kind of obscure service name. But if we look at the YAML, we'll see that this is the service export we've deployed for this service export, this service, and this is its IP now, and it's discoverable between both clusters. So if we go to the east cluster, we'll be able to see that these services are also being deployed to the east. Yep. See here. So, and it's obviously a different IP because each service needs to have local IPs that it uses inside the Google Mesh Hub, however that magic works. So I'm just going to keep kind of refreshing here until we have 3 of these cluster IP services, because remember we just deployed 2 of the service exports in Central, and we deployed 1 service export in East. So we should see 3 services. Right now it's 2, so we're going to give it a few more minutes. Okay, so now we have 3 of these service exports or imports happening in both clusters. So it seems like that syncing has happened between both clusters. And now it's time to deploy a Vitess cluster in our central region first, because it's kind of where the global etcd cluster is. I'm going to go back here to central, and let's first try and understand what we're actually deploying and how this connects. So this is a regular Vitess cluster coming from the operator. We're deploying inside the VoIP namespace. We're just giving it a name of DB. And the most important parts are here and here. So first, we are deploying an external global lock server. Since we've already deployed the etcd cluster in both data centers, we're defining an external etcd lock server. And we know that this is the address of the lock server because we've specified it as such in our global etcd YAML right here. So Google requires that that this is the it's called clusterset.locals domain that it creates, this internal domain using Cloud DNS. And we are determining that this is our global lock server. The next thing is a federation needs to be enabled right here. And we are defining our cells here. Right here we have central, and we are saying that the central lock server, the cell local lock server, points to central, and we've deployed that service export and etcd cluster as well. And then the only other important flag is the cells to watch. We want to make sure that both of our clusters are in here. And then we're just defining our cell here as central, our key spaces, the database name, which is Vitess, a few other config parameters here, some overrides. And then this is where our custom VT-gate service is, so that we can know exactly what we're connecting to, instead of using the deployed VT-gate service. We're just going to create our own here. It's not necessary, but we're also defining ACLs, which is not necessary either, but just for the sake of the demo, here they are. And then some boilerplate stuff here, and then some orchestrator config. This is all pretty much default as well. And then in the other, in the East cluster, we're doing something very similar. This is the same exact config, except we are swapping out Central for East, as you can see here, and defining our global address here for our global lock server. Our local lock server is East, and with the same root path, as well as the cells to watch being East and Central. So the only difference in these two Vitess cluster manifests is this address, and anywhere where Central is, East is now in this config. So they're identical otherwise. So pretty simple deployment. I'm going to go ahead and deploy the Central first, get it up and running, make sure all the pods are running, make sure that everything is okay before we go into East and deploy. Let's check out our workloads here in Central, and we're just going to start seeing these pods come online. Okay, so as you can see, everything is deployed here. It's all up and running. Quick note here, the reason that I deployed the etcd lock servers, as far as the global and the cell local lock servers, outside of my primary Vitess cluster operator config, is that if you rely on the Vitess operator to deploy those etcd lock servers for global and local, they generate random service names, and we would then need to be able, we would then have to edit these global lock server addresses in our configs in order to you know, after the fact, like after Vitess deploys the global and local lock servers. So I just went ahead and separated them in the two configs, just deployed the etcd lock servers on their own, using the operator still, but using a service name that I can control and know what it is. So now we've got everything up and running here. Let's make sure there's no errors in the VTCTLD. Yep, so we're looking good here. We're getting good health checks on the central tablets. Yep, we're serving tablets now, and we can see everything kind of connected here. So I'm going to go ahead and connect to orchestrators so you can see what the cluster looks like now. And I've just got this port forwarding bash script that I'm going to run here to connect, and we can open it in our browser to see what orchestrator is saying about our cluster. So we got the database instance, or the key space Vitess, and we can see that we have a master ending in 1.8, and we have a we have a read here ending in .14. So cool, looks like we're kind of up and running here. I can probably at this point connect to MySQL. Yep. Use show tables, and there is none, but we're gonna add some later. All right, cool. So everything is up and running in Central. Let's deploy. Let's go into East. Now that we're in East, I'm going to deploy the East cluster. Let's go over to our East cluster. All these pods get spun up here. Okay, cool. Looks like we're up and running in East. And I'm just going to check with VT CTLD and make sure there's no errors here. So you can see that we're now serving successfully the VT tablets in the central data center. So obviously Vitess in the East cluster has discovered the local cells and the global cell in the other data center, and as well as its own tablets here. So that's it. We're up and running. We have a multi-region cluster. We're able to communicate between the two. Vitess in both regions, as well as VT-Gate, is able to discover both of the all of the tablets in all of the regions. Let's look at the VT-Gate logs and see what we're dealing with here. So yep, so it is discovered the central VT tablets as well as the East VT tablets.
Open your eyes. What can you see around?
Let's pull up Orchestrator again.
Wind of the open sky.
I'm going to go back to our other cluster,
Follow the siren sound.
and we're going to take a look at Orchestrator to see what it's doing now.
Getting the royal scar. Holding a diamond blade.
Cool, so now we have more tablets. We can see that this is still the master. This is still, these are defined by data center as well. So the orange is central, the East is blue. And I could actually take one of these and elect it as master. So let's go ahead and do that. We'll just know that this tablet right here ends in 1.10. So let's just go ahead and drag this over here, promote this to master, and then it's going to take a minute. I'm going to go ahead and connect to MySQL again. And I can just show tables just to confirm that we're still connected. We're still able to run queries, select queries at least. In fact, while all this craziness is taking place, I'm going to create a table called testing. I'm going to insert something into testing and select testing. Cool, so I have this ID of 10, and I will confirm this by, well, first I'm going to make sure that we're about to get a new master here. So let's see what happens. Let me go ahead and refresh this. Seems like the change hasn't happened yet.
Tell me you got the wrong guy. Open your eyes. What can you see?
Okay, just to prove that we have replication happening between data centers, I'm going to go ahead and disconnect from the central data center. I'm going to connect back to the east data center. I'm going to forward ports again to VT gate. I'm going to connect back to MySQL, and we're going to select from testing. So we can see in the east data center that our data is still here. So I'm going to go ahead and update this record and connect back to the other data center to show the replication. Update testing, test where test equals 10. So now it's 18. I'm going to disconnect. I'm going to switch back to central, board ports again, connect back to the cluster in central. Testing, it should be 18, and it is. Cool, so we have replication happening there. Okay, cool. That is that's pretty much it. Any of the links and references that I've described here will be linked below in the video. The whole demo is there for you to deploy your own GKE cluster with Vitess in multiple regions.